It's Ty Warner with KISSsoft Tech Support and Taika Engineering. I want to talk about this new KISSdesign. You can see it's up here. It's a system module. I made a quick little intro video the other day. I want to talk a little bit about migrating legacy information or legacy data from your prior KISSsoft files. So the first thing we're going to do, though, so maybe I have a gearbox and I've got it split into a couple of modules with KISSsoft. I've got some gear files, maybe some shaft files. If I open up my KISSdesign, I get my general interface, and I'm going to create a two-stage gearbox that I already have designed, but maybe I just have the shafts and the gears are made in separate modules. I'm trying to manage these things and make sure that the speeds from the gears are right with the speeds from the shafts. What I can do is I can very simply migrate some of that information into KISSdesign and let that manage it all for me. So what I'll do is I'll start with a shaft. Actually, I'm going to start with 3 shafts because it's a two-stage gearbox. And I enter these in like that. Double click to start the shaft, double click to stop, and then you click to put the dotted blue axis on it. I'm going to change this name to input. This one I'm going to call intermediate. And this one here, we'll call this output. Okay. So now I have an input intermediate shaft and an output shaft. And I need to start populating these. And it's really easy. Every time I come in here, and it's maybe not too hard to see, but if we run this on this node, you see that little square box? If I right click on there, it allows me to enter my machine elements. So I'm going to first start off with a bearing called roller 1. I'm going to create another bearing, roller 2, rolling 2. I'm going to create a gear, and I just go to that node, I right click and I enter a gear, and then I'm going to add a coupling. All right, so here's my coupling: rolling 1, cylindrical 1, rolling 2, and coupling 1. And it's in order: roller bearing, gear, roller bearing, coupling. On the intermediate shaft, I'm going to do the same thing. I'm going to add, right click on a node, I'm going to add a bearing, I'm going to add a gear, I'll add a second gear, and I'll add a bearing. Okay, and you notice these are putting in it's automatically incrementing by 1. The output shaft, we still want to do that one, and we're going to right click and add a bearing. We're going to right click and add a gear, right click, add a bearing, and right click, add a coupling. Okay, so now if you look at this, I have a pretty well defined, I have a pretty good idea how these things are going to work, right? I've got an input shaft, I've got a gear, somehow these are going to connect, and then I've got couplings. And now what we're going to do is we're going to connect the gears. We're going to grab this pinion. We're going to, oops, that's not what I wanted to do. Get back up here. Get back over here. There we go. I don't need these nodes here, so I'm going to, oh, I see I had this thing selected. I'm going to get rid of these nodes. I don't need those. I'm just going to delete that node. So I'm going to, we're going to left click and drag down for mesh, left click, drag down for mesh. Okay, now I've got this gear driving this gear, this pinion driving this gear. Well, it's going to be a pinion anyways. We have a basic rough sketch of a two-stage gearbox. Pretty simple, pretty fast. I can simply now create my power boundary conditions, my power flow. I can right click on this coupling, add a boundary condition. The same with the bottom coupling. I'm going to add a boundary condition. You'll notice in my kinematics now, I've got my boundaries, both 1 and 2. I'm going to control torque and speed on the input. With newton meters and torque. I'm going to reference this as boundary 1. I'm going to reference this as boundary 2. I have a speed to 1 ratio of 1 to 1. That's fine for now. We're not going to constrain anything on the output because we just want to see what the torque and speeds are. Our kinematics are set at this point. I go back to my sketcher, and I'm probably trying to figure out, the next thing is I got to build these shafts, or I got to do these gear calculations. Down in the element view, I can select any of these to see. I've got gear contacts, and I've got pair 1 and pair 2. If I open gear pair 1, it'll open up a submodule for KISSsoft right here. I open this up, and I have a 20 and a 20, and I've got some general information here, but it's not what I want. It's not the file. I do have a file, actually. And the file that I want to run is, I'm going to open it, and I'm going to read it in. So I go to my video tutorials here, and I'm going to grab the stage 1 gearbox. And now I've opened it up, and I have all this information in here. It's going to run the calculation quick. And I'm going to check in my factors tab. I'm going to turn these shaft files off because I don't need those. And I'm going to change this over to a calculation method. What I'm doing is I'm disconnecting all the shafts and everything from before. I'm going to let KISSdesign do that for me. I shut this off. It asks me if I want to sublock this or lock this submodel. I do. And then I'm going to grab the second calculation. And I'm going to open up that file as well, which is going to be stage 2. My videos. And that populates it with that information. I look at my factors. I'm running this coordinate calculation method. I'm good with that. I'm going to lock it, say yes, and I'm going to run this calculation. Okay. So I run the calculation. And what do I have here? I have in the bottom, I have this results basic calculation. It's telling me my root safety. It's giving me my minimum, and it's telling me which element in my design is critical. Okay. This doesn't look terrible. If I were to open up the shaft file, I can double click on this input calculation. I've got 1, 2, 3, 4 nodes in here. A node defines a single outer contour. I don't like this. I have a shaft calculation file. I'm going to read that in. And I need to make sure that my shaft calculation file matches the naming conventions here. So when I open this, my input shaft here, and it automatically converts everything over to my input shaft. But I had to make sure my naming conventions were correct. Now when I close, I'm going to lock that submodel. If I go to my 3D viewer, my shaft came in, and my 3D viewer's got some stuff going on here, but that's because I haven't finished everything. But I have my gears, and I have my first shaft. I'm going to do the same thing with the intermediate shaft. I'm going to double click. I can see I've got 4 nodes. I'm going to simply open up this intermediate shaft right here. It reads this in, resets my bearings, all of it, all at once. This is legacy transfer. I lock it. I'm going to rerun. And I'm going to do the same thing with the output shaft. I select output shaft. Here's my output shaft. I'm going to simply come in, read my output shaft right here. It updates everything to what I need. And then I close this. I lock it, and I say yes. We're almost there for the complete gearbox design. There's a lot of things we can do that we won't show just quite yet, but let's set the intermediate design right here. if I select this intermediate shaft, you can see on the other side, come on, you can see on this other side, on the right-hand side of the software, I have these shaft calculation position, and we want to position it in accordance with the input calc. So when I make that change, I can do that. So my file name here, though, I'm going to turn this off because I don't need that. It's actually the cylinder 1, cylinder 2. So when you pull those in, it's going to pull in this designation from where you pulled that file. Okay. I update, and it locates my shaft exactly where I want it to be. Output shaft is similar. I'm going to turn this off because I don't want it connected to that file that I read in. I'm going to make sure this is turned on. I update, and it is where it needs to be. My input shaft, however, I can deselect this and deselect that. I want it to be at the origin. I update, and we're still at the origin. I now have a legacy gearbox with the data that we previously made entered into KISSsys. When I open a gear pair calculation, as an example, the first one, I can run the calculation. If I go to my factors, I can turn on my Annex E, and now it's located back to my KISS35 input calc. It's a temporary document, my intermediate. So what I'm doing now is I've made sure that I'm connected just to the KISSdesign file, and now when I run it, I'm going to see an upgrade on my face load factor to 1. Well, that's pretty stiff. Well, I'm going to turn these on. That's why. Let's try it again. Should be 1.0 something. Better than 1.1. The shaft calculation goes in the background, 1.2671. And if I open up that calculation for the shaft over here, I can run a flank line modification, look at the meshing. Okay, I'll run this quick. .1458. A couple things I didn't do in here is I didn't update this system information. What I can do is I can go into the system data here, change this to 500 hours, and then I'll update this, and some of these numbers will update. And by the way, you can add to these system data files. I can hit a plus. I can define if it's a shaft gearing and a bearing. If it's just for shafts, cylindrical gears, reliability, calculation method. If I say it's just gears, maybe I want to look at gear on shaft axis alignment, or whatever it might be. I've already got service life. Maybe safety. I think I want to see safety. Nope, I wanted to see gears. Axis alignment. I mean, there's lots of things we can add on here. So, and if I don't want something on here, I can just go turn it off. And I can activate and swap and do lots of things here for my system design. Now if I go back to my shaft, see which one do I want. Gear pair calc. And now if I look at my factors, it's all here. I can run contact analysis. Maybe I want to run high and I want it to be according to 1. I size my coefficient of friction, and I run this quick. My axis alignment should already be set. The shaft calculation is running, and I'll get an idea of what my contact pattern looks like real briefly. So anyways, the point of the little video here is I want you to understand that KISSdesign, you can migrate some of that legacy data and create your full system gearboxes pretty quickly. So this is 15 minutes of a little bit of work, and I'm able to get a pretty good grasp on what I think my um, my tooth contacts are going to be in this particular design. And if I were to open up a shaft file, I would know that that shaft is bending or deflecting a certain amount, and it's giving me this contact pattern. And then from here, I can optimize with modifications. So here is just another kind of brief glimpse with KISSdesign. I think it's pretty fast. It's faster than KISSsoft, KISSsys, and I think it's a little bit easier to kind of swallow in terms of like the visual building portion of it, how quickly you can add your elements. So KISSsoft is doing a good job there. We close this, and we're back here. We can save this. It'll save as a S20 file, and we'll just call this example. And it's and now it's here. And as we progress, we'll try and show some more videos. There's offsets. There's ways to position shafts and stuff. I'll try and run those as a separate little video. But this is a pretty good module. KISSsoft is on something here, and I think it's going to be really good. It's only going to get better in the next couple of years. So thanks for watching. Subscribe if you want. We'll try and get videos out as often as we can. Really interesting videos. When someone does something that's maybe pushes the limits, and we'll try and show what that is. So thanks again for watching. Take care.